Welcome, my friends. Suppose that the price P of t of an antique desk is increasing over time, where t is the number of years from today. The function is P of t is equal to 10,000 times 1.042 to the tth power. Let's answer a few questions about this antique desk. First, what is the current price of the desk? Well, since t represents the number of years from today, the current price of the item must be 0 years from today, when t is equal to 0. So let's plug in t equals 0 into the function. We have 10,000 times 1.042 to the 0 power. We know anything to the 0 power is equal to 1, so we have 10,000 times 1, which is just 10,000. The price of the antique desk is $10,000 today. Next, does this function represent exponential growth or decay? Well, the way we can tell is based on the number that is raised to the power, which in this case is 1.042. Here's how you know. If the number inside the parentheses is greater than 1, you have exponential growth, something that is increasing over time. If the number is between 0 and 1, then you have exponential decay, something that is decreasing. In this case, we have 1.042, which is greater than 1, indicating that the price is increasing exponentially, so we have exponential growth. Now the 1.042 also tells us the rate at which the price of the desk is increasing. The part after the decimal is 0.042, which is the decimal equivalent of 4.2%. You can also subtract 1 from 1.042 to get 0.042, which is the decimal equivalent of 4.2%. If you aren't sure, you could just multiply 0.042 by 100, which will give you 4.2. That means the price of this desk is increasing by 4.2% per year. We could answer a question like, what will the price of the desk be in 10 years? Just plug t into the equation and you will have the answer. P of 10 is equal to 10,000 times 1.042 to the 10th power, which is equal to 15,089.58 if you plug that into your calculator. So the desk will be worth $15,089.58 in 10 years. Let's try another one. The population of a city, P of t, is in decline and is measured by the following function, where t represents the number of years after 2020. P of t is equal to 150,000 times 0.96 to the tth power. Do you think this represents exponential growth or decay? Well, this is exponential decay, as the base of the power t of 0.96 is between 0 and 1. By what percentage is the population of this city decreasing each year? This is a bit tricky. The 0.96 tells us that each year, the population is 96% of what it was in the previous year. Well, if each year the population is 96% of the previous year, that means there must have been a 4% decrease. 100% of the previous year would represent no change, so 96% must represent a 4% decrease. Another way to think about it is to take 1 and subtract 0.96, which would give you 0.04. The percentage equivalent of 0.04 is 4%. So that means the population of this city is decreasing by 4% each year. What will the population of this city be in the year 2027 if the trend continues? Well, t is the number of years from 2020, so t equals 7 corresponds to 2027. Plugging in 7, we get P of 7 is equal to 150,000 times 0.96 to the 7th power, which is equal to 112,717.12. The population will be about 112,717 in the year 2027 if the trend continues. Let's try a few more where you need to build the equation. The half-life of a radioactive isotope is the time it takes for a quantity of the isotope to be reduced to half of its initial mass. If we begin with 140 grams of an isotope, how much will be left after 6 half-lives? Round your answer to the nearest gram. Let's let h represent the number of half-lives and m of h be the mass of the isotope remaining after h half-lives. Well, the original mass is equal to 140, but after 1 half-life, we would need to multiply by 1/2 to get 70 grams remaining. For 2 half-lives, we would have to multiply the first half-life of 70 amount by 1/2 to get 35. But that's the same thing as multiplying the original amount by 1/2 twice, or 1/2 to the second power. If we want to have a function that works in general, it's going to be better to have it expressed in terms of our initial value of 140. Hopefully you are seeing the trend. For 3 half-lives, we would have 140 times 1/2 to the third power. Or in general, for h half-lives, we have m of h is equal to 140 times 1/2 to the h. The question asks how much will be left after 6 half-lives, so let's plug into the formula. M of 6 is equal to 140 times 1/2 to the 6th power. If you plug this into your calculator, you should get 2.1875. Rounding to the nearest gram, about 2 grams will remain of this isotope after 6 half-lives. Consider an investment that increases in value 4% per year, sometimes referred to as compounded annually. If $6,200 is invested, how much will the investment be worth in 8 years? This problem is similar to the last one, so I encourage you to take a moment to see if you can solve it on your own. Pause the video and give it a try. Let's let A of t represent the amount the investment is worth after t years. The amount starts at $6,200, but then the investment increases by 4% per year. So we have 6,200 times 1.04, where the 1.04 represents 104%, meaning the investment next year will be 4% more than it was the previous year, or 104% of the previous year's value. This needs to be raised to the tth power, as 6,200 would need to be multiplied by 1.04 t times in order to find the value of the investment after t years. Altogether, we have A of t is equal to 6,200 times 1.04 to the t power. If we want the balance after 8 years, just plug in 8 for t. We have A of 8 is equal to 6,200 times 1.04 to the 8th power, which, if you plug into your calculator, you will get 8,485.13. This investment will be worth $8,485.13 in 8 years. Alright, my friends, that wraps up our video over word problems related to exponential functions.